This video is from the prerequisite chapter, P.7. It's all about complex numbers. Okay, so here we go. We have a few examples to work. This first one, we need to get this I out of the denominator. We multiply by 1, but since there are two terms, we use the conjugate of the denominator. So multiply 8 times 2. 8 times negative I times 2, and negative I times negative I. In the denominator, 2 times 2, 2 times negative I times 2, and I times negative I. Combine like terms, we have 16, negative 8i and negative 2i is negative 10i, and then I squared is negative 1. In the denominator, we have 4, negative 2i plus 2i is 0, so we have minus I squared, which is negative 1. In the numerator, 16 minus 1 is 15. In the denominator, we get 5. Now we just need to split this into real and imaginary. So we have 15 over 5 minus 10i over 5, which will reduce to 15 over 5 is 3, 10i over 5 is 2i. Let's go ahead and try number 2. I have a feeling I'm going to run out of room on this one. So let's see, we multiply by the conjugate, we get 5 plus 4i. Well, when you multiply the numerator, you just get 5 plus 4i. What about when you multiply the denominator? 5 times 5 is 25, 5 times 4i is 20i, negative 4i times 5 is negative 20i, and negative 4i times positive 4i is negative 16i squared. So you end up with 5 plus 4i all over, these two go to 0. Let's see if we can do this in our heads. We have 16 times I squared, but I squared is negative 1. So we have negative 16 times negative 1. That's positive 16. And 25 plus 16 would give us what? It would give us 41. So in the denominator, we just get 41. So what if it looks like number 3? We don't need a conjugate because it's just one term in the denominator. So we just multiply by I over I. This would give us 3i minus 2i squared, because you have to distribute the I, all over I squared. Well, remember, I squared is negative 1. And negative 1 times negative 2 is 2. And remember, the real part goes first. So you have 2 plus 3i all over I squared, which is negative 1. When you divide by negative 1, you actually change all the signs. So you get negative 2 minus 3i. Finally, number 4. This one is two terms, so we need to multiply by the conjugate, 1 minus I. Distribute the 4. We'll come over here. So we have 4 minus 4i all over 1 times 1 is 1. 1 times I is negative I times 1 is I. And I times negative I is negative I squared. So we have 4 minus 4i all over. This is 0. I squared is negative 1. But minus a negative 1 would be a positive 1. So we get 1 plus 1, which is 2. Remember to split it up. We get 4 over 2 minus 4i over 2. So that's 2 minus 2i. A few more examples. The square root of negative 2 plus the square root of negative 18. Well, before you do anything with these, you need to simplify them as much as possible. If you have the square root of a negative 1, remember that's the same thing as I. So if you have the square root of negative 2, isn't that the same thing as the square root of negative 1 times the square root of 2? So you just get I square roots of 2, right? So this simplifies into I square roots of 2. What about the square root of 18, negative 18? So we have our 18, and it's negative. So we know it's negative 1 times, break this all the way down. You guys should know how to do that by now. We can say that's 2 times 9, but 9 is 3 times 3. And that's all under a square root. Well, we know the square root of negative 1 is I. These two get to come out, but only one makes it. And then we keep the 2 inside. So this turns into 3i square roots of 2. Both of these have i's, and both of these have square roots of 2. That makes them like terms. If they're like terms, you can add them. This is like 1i square root of 2 plus 3i square roots of 2. That'll give you 4i square roots of 2. So how about number 6? We have negative 4 plus the square root of negative 50 over 4. The square root of negative 50. So we can break that down into negative 1 times. We know that's 2 times 25. So 2 times 5 times 5. That's all under a square root. This is going to be I. These get to come out, so we have a 5. And the 2 has to stay inside. So we have negative 4 plus 5i square roots of 2 all over 4. Now to keep this the way it's supposed to be, you should split this into real and imaginary. So you'd have negative 4 over 4, which is negative 1, and then negative 5i square roots of 2 over 4. So that would be your final answer. What if you're trying to multiply, like on number 7? We need to distribute this one. Well, you need to break them down as much as you can first. So we have the 27 and it's negative. 27 would be, that's negative 1 times 3 times 3 times 3, right? That's a square root. So the square root of negative 1 is I. These are partnered up, so 3 gets to come out, but this 3 has to stay inside. So we have 3i square root of 3 times, what's the square root of 9? That's 3 minus, and the square root of negative 2 we did right here. It's going to be I square roots of 2. Now we can distribute. 3i square root of 3 times 3 is 9i square root of 3. 3i square root of 3 times negative I square root of 2 is going to be negative 3i squared square root of 6. But what is I squared? I squared is negative 1. What's negative 3 times negative 1? Positive 3, right? So you would have positive 3 square root of 6. That's a real part. So when we write our answer, we write it as 3 square roots of 6 plus 9i square roots of 3. This would be the final answer. How about the last problem? We have 2 minus the square root of negative 12 all over 2. So break down the 12. That's negative 1 times 2 times 6. So 2 times 2 times 3. Negative 1 gets to come out as an I. The 2's get to come out, but the 3 has to stay inside. So we have 2 minus 2i square root of 3 all over 2. Split it up, so you have 2 over 2 minus 2i square root of 3 over 2. Reduce those and you get 1 minus I square roots of 3.